Hi, my name is Amir. I lead the cloud platform engineering at Anyscale, and I'm very excited to introduce you to Anyscale. In the next few minutes, I will show you how Anyscale lets you easily build and deploy scalable AI applications. During development, you get to develop directly on your laptop, and when you're ready to go to production, you can build reliable and automated workflows using production jobs and services. First, let's see how easily you can develop interactively at scale using Anyscale. Here we have a Python Ray application that builds an image recognition system by training and tuning a ResNet model on a small dataset of 50,000 images. I start by running this locally. I can simply run Python script, and this will run it locally on my laptop. At some point, I'm going to have to scale this up to either train on a larger data set of images or perform large-scale hyperparameter tuning to get the best model. Anyscale makes this easy because I can take the same code, set ray address variable, and make it point to Anyscale, and give it a name, for example, ImageRec. Anyscale handles the rest, creating a cluster, connecting to it, and scaling up for my application. In this case, I want to use GPUs to accelerate the training. So I also pass -- use GPU. That's all I need to scale this up to the cloud. Anyscale will automatically provision the necessary resources, including CPUs and GPUs, conveniently package and ship my local dependencies to the cluster, giving me a fast iteration cycle on my application or model. Let's jump into the Anyscale console to see the details of my development session. Here you can see compute resources and incurred cost. Anyscale also provides access to built-in Jupyter, Notebook, and observability dashboard for monitoring. I can also have access to event logs and application and actor logs if I needed to debug my application. Interactive sessions on Anyscale are great because they provide an infinite laptop experience which combines laptop-like development with the computing scale of the cloud. My application would take more than 5 hours to run on my laptop, but it takes less than 5 minutes to run on Anyscale. Now that I've finished training the model, I want to set up a workflow to retrain it periodically as new data becomes available. To do this, I will use Anyscale jobs. When I submit a job, Anyscale takes over of all the DevOps around the job, starting a cluster, executing the job, tracking progress, retrying on failures for fault tolerance, and finally shutting down my cluster to reduce costs. To set up a job, I can either define a simple YAML file or pass in the parameters using the Anyscale API. Let's see an example job config YAML. This configuration tells Anyscale everything it needs to know to run the job. It will create a cluster on the specified cloud with a specified environment, load my cloud from a remote path such as GitHub or S3, and then the provided entry point will be run to run my code. What's great is that Anyscale is cloud agnostic. Let's say that I want to run this training on AWS. All I need to do is set the cloud parameter to AWS, and it will run on AWS. To submit this job, I run Anyscale job submit jobconfig.yaml. Here I am submitting my job manually, but I could also automate this by submitting it from a workflow manager or a CI/CD pipeline. Let's look at this job run in the Anyscale console. Anyscale keeps records of my previous job runs and provides access to job and cluster details, logs and events also to help me understand how it changes over time. Of course, many AI applications don't stop with just batch jobs. They also need to be served in an online fashion. For instance, I might need to make an endpoint available to other teams or, for example, end customers to be able to consume my image recognition model. Luckily, Anyscale makes this very easy. Anyscale services allow me to deploy my model behind a scalable HTTP endpoint. Even better, Anyscale runs my Ray application in a highly available manner, restarting it automatically if it becomes unavailable. Let's deploy a service that loads the trained model from earlier and serves it. To do that, all I have to do is use a similar config and run Anyscale service deploy service config.yaml. Anyscale will automatically start a cluster and autoscale it based on the incoming traffic to the service. To emulate the requests to our image recognition service, I have created a synthetic load generator that sends images to the API endpoint generated by Anyscale. I will pass that endpoint to the script and run it. And here you can see the responses being printed to the screen. Now I can go to Anyscale and I can see different performance and usage metrics such as queries per second, P95 latency, and exceptions. I can also easily integrate these metrics with my other monitoring tools like Datadog or Prometheus. Let's recap. In this video, I showed you how Anyscale empowers you to interactively develop your AI applications and scale them to run on multiple clouds without any code changes. I also showed you how Anyscale allows you to run batch jobs and deploy highly available services. Thank you for watching. We welcome you to try out Anyscale, and we are very excited to see what you will build on Anyscale.